All right, everyone, good evening. My name is Eric. I'm here for week 4, day 2, giving you your lecture. Today we will be talking about AWS Virtual Private Cloud Components. Yesterday, you guys went over LANs, WANs, MANs, VPNs, so local area networks, wide area networks, domain name systems. You guys also went over the network topology. Today, we are continuing further into networking by actually building our own network within AWS. You guys will learn more about VPCs, so virtual private cloud, subnets, routers, security groups, and much more. So our first lesson will deal mainly more with getting to know the different components within AWS. And then our second lesson will involve a lab where we will actually get hands-on experience and build our own network within the AWS console. And then we also have a challenge for the day. The challenge will be creating a network and deploying an application within it. So, are there any questions before we get started? No questions? Okay, let's go ahead and start with lesson one. First things first, we're just gonna go ahead and go through this lesson one, and then I'll also show you guys a chart at the end, just so you guys can visualize how everything is set up and what the different components are. So let's go ahead and get into routers in AWS. It gives us a bunch of different examples, including Internet Gateway, Virtual Private Gateway, NAT Gateway, and Transit Gateway. So in AWS, a router is a virtual or physical device that forwards packets between networks. It is responsible for routing traffic between different networks, such as between a VPC and the internet, or between VPCs within the same region, or across different regions. So kind of think of it like a traffic controller. It just redirects everything that's coming through the network and sends them where they need to go. So our first example is the Internet Gateway. This is, in short, a connection from your network and your VPC to the internet. So this is a VPC component that allows instances in your VPC to connect to the internet. It is a virtual router that connects your VPC to the internet and is a default target for all internet-bound traffic from your VPC. So everything that's going outwards that needs to go to the internet is going to hit this internet gateway first. Virtual private gateway. This is a VPC component that allows you to connect your VPC to another network, such as an on-premise data center or another remote VPC. It is a virtual router that connects your VPC to another network using a VPN or direct connect connection. So it's pretty much what routes the traffic between networks. So if you have a VPC and you want to reach another VPC, you would use this, or like it says, if you are trying to reach a on-premise data center, then you would include this as well. Next up is NAT Gateway. This is a VPC component that allows instances in a private subnet to connect to the internet or other resources outside of VPC. It is a virtual router that routes traffic from private subnets to the internet and is the default target for all internet-bound traffic from private subnets. So a NAT gateway attaches to your public subnet. So let me retract a little bit. If you have a VPC and you have two subnets within it, you have a public and a private. Your NAT gateway will sit on your private subnet or public subnet, excuse me, so that your private subnet is able to reach the internet through connecting to the NAT gateway and then back out to the internet. So your private subnet is not going to be able to reach the internet if it doesn't have the NAT gateway because it's not public. But your public subnet, of course, public, it's able to reach the internet through the internet gateway, if that makes sense. You guys will, as you continue on and start building, it will start making more sense. So You'll get more experience later. Transit gateway, this is a VPC component that allows you to create a central hub for routing traffic between VPCs, on-premises data centers, and remote networks. It is a virtual router that connects multiple VPCs and networks together and allows you to create a network topology that spans multiple regions and accounts. So this is pretty much, think about how if you have, let's say 5 or 10 networks in a circle, you guys learned about the topology yesterday. So say if you put the transit gateway in the middle, it will redirect all the different traffic to the different networks that are surrounding it. Route table should have been included in here, but you're going to be working a lot and building route tables today. So I guess it is good that it has its own section. So does anybody want to read the uh, first 2 paragraphs?
In Amazon Web Services, a route table is a set of rules that determines where network traffic is directed. It is associated with a subnet in a virtual private cloud and determines how traffic is routed between subnets to the internet and to other networks. Each subnet in a VPC must be associated with a route table, and route tables can be associated with one or more subnets. A route table consists of a list of routes, each of which specifies a destination and a target. When a packet is sent from a source to a destination, the route table is consulted to determine the target for the packet. The target can be an internet gateway, a virtual private gateway, a peering connection, or a network interface.
All right, someone else read the next 2.
For example, a route table might contain a route that sends all traffic designated for the internet 0.0.0.0/0 to an internet gateway, and another route that sends all traffic destined for a specific network 172.16.0.0/12 to a virtual private gateway. A similar demo will be shown later, which creates a custom VPC using a public and private subnet. While the route table sends all traffic destined for the internet to an internet gateway, all other traffic is sent to the private subnet mask.
Okay, and someone else to finish the paragraph off.
Starting where?
Starting from you can create.
You can create multiple route tables in a VPC and customize the routes in each one to meet the specific needs of your network. You can also modify the route tables at any time to add, delete, or update routes. Note, in addition to route tables, AWS also provides a feature called Transit Gateway that allows you to create a central hub for routing traffic between VPCs, on-premises data centers, and remote networks.
Okay, so in short, a route table is pretty much takes in traffic, and depending on what configurations you set it to, it is able to send those different traffics to different IP addresses or different locations. So that's that 0.0.0 that means anywhere. So the target for this example is the internet gateway. And then this one right here, this IP address would get sent to, say, an EC2 instance.
Hey Eric, I have a question.
Yeah.
We learned about Nginx. When I was reading through this, it kind of sounded very similar. I looked it up online and it said like Nginx is more like the routing on the application layer, and then route tables more of the network layer. But aren't they all using IP addresses?
In terms of,
Like either Nginx or and the route table?
uh, let me actually look up if Nginx uses
I don't mean to put you on the spot, but I'm just like, if anyone knows, like it'd be, I'm kind of scratching my head about that.
You'd want to look up the OSI model, Cam. Like if you Google OSI model,
Mm-hmm.
and it's a 7 layers, like physical, data, network.
Mhm.
Do not throw it's please do not throw a sausage pizza away. It's the acronym for the
Oh,
7 layers of
mnemonic. I
OSI.
love mnemonics. Okay.
Yeah, so if you
Okay.
Google OSI model and please do not throw away sausage pizza, IP addresses are in the want to say the network layer, level 3.
Okay.
Nginx is a web proxy that is in the application layer, which is like layer 7 at the top, if you think about it that way.
But the web layer also uses IP addresses as well, right? Not
Yes, but
necessarily all the time.
it goes down the stack.
Okay.
Like the web service is a higher layer than the network layer where IP addresses reside. Like IPs, I think, are layer 3 and maybe layer 4.
Okay, I'm gonna Google it. Thank you guys.
Yeah, thank you, Patrick. Okay, any questions so far on any more questions so far on what we've covered or any other questions you may have? Okay. We're gonna go ahead and keep on going. This route table would be associated with one or more subnets in the VPC. When a packet is sent from a source within the VPC to a destination, the route table is consulted to determine the target for the packet. If the destination is within the network, which is this IP address, the packet would be sent to VPG1. If the destination is outside the network, the internet, the packet would be sent to IG1. So this pretty much talking more about route tables. So this diagram right here is associated with the route table called my VPC RT. It doesn't say it on here, but it would probably like be over here in this area right here, just in between everything. Each subnet is associated with a route table. Take note of that. That determines how traffic is routed between the subnets and the internet. For example, the route table for subnet 1 might contain a route that sends all traffic destined for the internet to IG1, and another route that sends all traffic destined for a specific network to VPG1. When a packet is sent from a source within the VPC to a destination, the route table is consulted to determine the target for the packet. If the destination is within the network, the packet will be sent to VPG1. If the destination is outside this network, the packet would be the packet would be sent to IG, the internet gateway. The router is then responsible for forwarding the packet to its destination. So everything we've just been saying, it just redirects traffic. Internet gateway, we were saying how it connects the VPC to the internet. Anybody want to read this section right here?
An
Right.
internet
Internet
gateway is
gateway.
a VPC component in Amazon Web Services that allows instances in your VPC to connect to the internet. It is a virtual router that connects your VPC to the internet, and it is the default target for all internet-bound traffic from your VPC. An internet gateway is a necessary component of any VPC that needs to connect to the internet. It provides a connection between your VPC and the internet, allowing instances in your VPC to communicate with resources on the internet and allowing internet traffic to flow into your VPC. As shown in the last diagram, that if the destination is outside of this network, for example, the internet, the packet would be sent to IG-1.
Any questions on the internet gateway? All right, can someone read the next two paragraphs in security groups? Think of security group as a firewall.
In Amazon Web Services, a security group is a virtual firewall that controls inbound and outbound traffic for one or more Amazon Elastic Compute Cloud instances. It is a set of rules that specify which traffic is allowed to reach your instances and which traffic is blocked. A security group acts as a virtual firewall for your instances and is associated with one or more instances. You can create multiple security groups and assign them to your instances. When you create a security group, you specify the rules that control the inbound traffic to your instances and the outbound traffic from your instances.
Okay, can someone finish these next four paragraphs?
For example, you might create a security group that allows incoming traffic on port 22 SSH and port 80 HTTP and allows all outbound traffic. You can then assign this security group to an EC2 instance running a web server. allowing users to access the web server over the internet via HTTP, and allowing the web server to access the internet for updates and other purposes. You can modify the rules of a security group at any time to add or remove traffic. You can also change the security group that is associated with an instance at any time. Security groups are an important part of the security architecture of your VPC and can help you control access to your instances and protect them from unauthorized access. Here's an example.
So over here in the example, you have your EC2 instance and your security group. Think of it as the bouncer. It lets traffic in or it doesn't let traffic in. And then you have your network and then the internet. So in this diagram, an EC2 instance is running within a virtual private cloud and is associated with a security group. The security group acts as a virtual firewall for the instance and controls the inbound and outbound traffic for the instance. The security group has rules that allow incoming traffic on certain ports, 22 for SSH, 80 for HTTP. Uh, Always remember these. These are important and allow all outbound traffic. This allows users to access the instance over the internet via SSH or HTTP and allows the instance to access the internet for updates and other purposes. The VPC is connected to the internet via an internet gateway. Any questions on a security group? And then network access control list. You guys aren't going to be using an ACL today, but you will in the future. So it's also good to know. In Amazon Web Services, a network access control list is a set of rules that controls traffic flow to and from one or more subnets. So an ACL is kind of similar to a security group, but a security group is dealing with an instance, but the ACL in this case is dealing with a subnet. So it's on different scopes. So it controls the traffic flow to and from the subnet in a VPC. Each rule in an ACL specifies a protocol, source IP address range, and destination IP address range, as well as an action, which is allow or deny, to take on traffic that matches the rule. You can use ACLs in AWS to allow or deny traffic to your VPC based on the IP address, protocol, and port number of the traffic. You can also use ACLs to secure your VPC by limiting access to authorized devices and users and blocking unauthorized traffic. ACLs in AWS are stateless, which means that they do not maintain any information about the traffic that has passed through them. This means that you must create rules for both inbound and outbound traffic if you want to control both types of traffic. You can create and manage ACLs using the AWS Management Console, the CLI, or SDKs. You can pretty much manage a lot of things within all of these. You can also use ACLs in conjunction with security groups, which are another layer of security in AWS that allows you to control inbound and outbound traffic at the instance level. Here's how example of how the ACL works. Traffic is generated by a device or user on the network or from an external source. The traffic is transmitted to the network or host that has the ACL configured. The ACL checks the traffic against its rules to determine if the traffic is allowed or denied. If the traffic matches a rule that allows it, the traffic is forwarded to its destination. If it's denied, it goes back. It might try this one. ACLs can be implemented in hardware, such as in a router or a firewall, or in a software, such as on a network operating system or a virtual private network, or VPN. They're used to secure networks by limiting access to authorized users and devices and blocking unauthorized traffic. Now we're gonna get into elastic IP address. It's a static public IP address that you can assign to your AWS resources, such as EC2s, network load balancers, and Amazon relational database service instances. Later on, during the lab, we are going to be attaching an EIP to the NAT gateway. So remember, the NAT gateway is the router that allows the private subnet to reach the internet, and the NAT gateway is within the public subnet. An EIP allows you to assign a fixed public IP address to a resource that can be accessed from the internet. This can be useful in a number of situations, such as maintaining a consistent IP address for a resource, even if that resource is stopped or terminated and then restarted. Mapping a domain to a resource, such as an EC2, using a DNS-A record, directing traffic to a resource in a VPC that is behind the load balancer or a CloudFront distribution. EIPs are charged on an hourly basis, even when they are not in use. But if it is attached to a running resource, then you are not charged. So in short, EIP is a static public IP address that you can assign to your resources to enable internet access and maintain a consistent IP address for those resources. NAT gateway or NAT network address translator in AWS is a network address translator is a device that enables instances in a private subnet to connect to the internet or other resources outside the subnet while hiding the private IP addresses of the instance from the outside world. AWS provides two types of NAT devices, a NAT gateway and a NAT instance. The gateway is a managed NAT service that provides internet access to instances in a private subnet. It automatically scales to meet the needs of your application and is highly available and resilient. The instance is a general purpose EC2 instance that you can use as a NAT device. It allows instances in a private subnet to connect to the internet or other resources outside the subnet while hiding the private IP address of the instance from the outside world. So instance and more so subnet. You can use a NAT device in a VPC to enable internet access for instances that do not have a public IP address, or to enable outbound internet access for instances that do not have direct internet access. In summary, a NAT device in AWS is a device that enables instances in a private subnet to connect to the internet or other resources outside the subnet while hiding the private IP address of the instance from the outside world. So how a NAT works, an instance in a private subnet generates traffic and sends it to the NAT device, which is within the public subnet. The NAT device translates the private IP address of the instance into a public IP address and assigns a new port number to the traffic. The NAT device sends the traffic to the internet and other resources outside the subnet using the public IP address and the new port number. And then the internet or other resources outside the subnet receive the traffic and send a response back to the NAT device. The NAT device translates the public IP address and the new port number back into the private IP of the instance and sends the response back to the instance. NAT device can be implemented in hardware such as a router or a firewall, or in software such as on a network OS or a VPN server. They're used to enable internet access for instances in a private subnet, or to enable outbound internet access for instances that do not have direct internet access. Any questions on what we went over?
This last one, the NAT, it acts like a doorman, let's say, right? So I tell somebody my address, but I don't give them my actual location. It'll be a doorman, and then he could go ahead and deliver it to me to my address. And then when I want it out, I give it to the doorman. The doorman will give it out to the world.
Yeah, that's a good analogy. Yeah.
Okay.
Yeah. Yeah, it's exactly like that. Any more questions? Okay. And as promised, I'll show you guys just a little visualization of how everything is kind of connected. So you have your internet out here, and then you have your VPC with a big rectangle. And then on your VPC, you have your internet gateway. So it's kind of like your little door. So the internet gateway within the VPC talks to the internet, and then your router. So AWS just whenever you create a VPC, it just automatically has a built-in router, so it knows where to redirect everything. But if there's traffic coming from the internet, it will reach that. The router will help it get to the right location. So this RT stands for the route table. So it will determine whether the traffic is good to go or where to redirect it. And then after the route table, it will reach the access control list. So the access control list is the bouncer for the subnet. So it just makes sure that everything that's coming through, it has a bunch of rules and has a list of what to let in and what to deny. So if you're on the allow list, it will allow you to reach the security group within the subnet. So let's go to the public subnet. Okay, so it'll reach the security group within the public subnet, which contains two EC2 instances. So after it reaches the security group, then the security group will determine whether you're allowed to reach the EC2 instances. So it's another bouncer. And then if it determines based on the inbound and outbound rules that, well, in this case, inbound rules since it's coming in from the internet, then it will pass you to the EC2 instance. Now going back out, so if you have the outbound rules configurations correctly set up, it will allow the traffic from the EC2 instance pass through the security group and reach the access control list. And then remember, there's an allow and deny list. So if it's denied, then it's not going anywhere. That traffic stays within the subnet. If it's allowed, it'll go back to the route table and it'll determine where to route the traffic. And then it goes to the internet gateway and back out to the internet. Does that make sense? Any questions on that? If there's no questions, let's go ahead.
Eric,
Yeah.
Eric, I had a question.
Mm.
In this diagram, it has two circles for route tables.
Yeah.
Is that a common thing, kind of based off of the number of subnets, or could you have one routing table that pushes out?
So you could have one route table, but remember you have to set up each route table differently.
Mm-hmm.
So for instance, this may allow traffic outwards to the internet, but this one doesn't because it's a private subnet. You have to reach the NAT gateway, which we can include over here.
And you couldn't do that under one route table?
No, because they have different configurations set up.
Okay,
You'll see that more later on when we get into the lab.
cool. Thank you.
Yep. Remember that route tables will usually be associated to its own subnet. So just think of it like that. But here's our little NAT gateway, and usually if you want the private subnet to talk to the internet, because you don't want to expose your IP, you connect to this first and you go back out to the internet. Kind of like what George was saying, it's a doorman. All right. Let's get into the lab. All right, so purpose of this lesson is to teach creating VPC and configuring the VPC with components. So learning objective, VPC intro, creating VPC, creating public and private subnet, and creating route tables. Those are the key players that you need to know about. So let me go ahead and move this to a new window. Go ahead and go to your AWS console home so you can just follow along. Or if you just want to watch so you can get the information first, that's cool too. That's usually sometimes I learn better that way too. Just give me a thumbs up when everybody's there. All right, let's get into it. So first thing you want to do is sign into your AWS console. You're gonna get to the console home. Within your search bar, you want to look for private virtual private cloud. Just type in VPC. And then once you reach the VPC dashboard, navigating through here, you're gonna be as you go on through the cohort, you're gonna be really getting comfortable with navigating through all these different links over here to the left panel. But the first one we want to check out is your VPCs. So go ahead and click on that. Once you reach your this page right here, it shows the list of VPCs that are currently available. And I believe this is a global scale, so it doesn't matter which region you're in. But let's double check. Never mind. I guess it doesn't matter which region you're in. All right, so I'm going to create mine in US East 1. Go ahead and create VPC. For the top setting, we want VPC only, and then we'll add all the other components ourselves. For name tag, go ahead and name it what you want. Put your first name and then just do Eric or your first name and then VPC or something. Just so we can identify which one's ours. Next block configures the IPv4 CIDR block. So CIDR stands for classless inter-domain routing. You don't really need to know what it stands for, but it is a way to write and manage IP address ranges. So we can divide networks into smaller parts and use addresses more efficiently. You'll get more into IP addresses tomorrow for tomorrow's class, as well as subnets and I forgot what else, but IP addresses and subnets you will get more into tomorrow. But for right now, I'll explain a little bit of what the IPv4 CIDR is or the IP range. So over here, you can see that it already has like a grayed out text that says 10.0.0.0/24. So let me just go ahead and put that IP. So this part right here is the starting IP address. This first beginning part right here. And then the /-24 is the network prefix. So you see down here in the gray text, it says CIDR block size must be between 16 and 28. The smaller the number, the bigger the network. So the more IP addresses you have within the range. And then the bigger the number, the smaller the network. So you'll have less IP addresses to use within that specific range. So this /24 would give me 256 usable IPs. So it's the 10.0.0.0, and it goes all the way up to 10.0.0.255. So there's 200. What is it? There's 254 in between between these two IP addresses. But then you add these two individually, you get the 256. And it's like that uh for all the different IP ranges that you will configure. As you work more with this, you'll start to notice a pattern. So it's okay if you don't understand this fully right now. But so /24 would give me 256 usable IPs. And we were saying that if it goes up, it becomes a smaller network. So if we go to 28, we'll only have 16 usable IPs. And you could kind of think of it as kind of backwards. So /28 would give you a 16 usable IPs. If you multiply those 16 usable IPs by 16, you'll get that 256. So that this goes to /24. And then, so now you have 256 usable IPs. If you multiply that by 16, you would get 4,096 usable IPs. And oh shoot, this should be a /20. So if you see the increments of the /, those network prefixes, we're going down by 4, but multiplying the usable IPs by 16. So again, this would have 4,096 usable IPs. If we go down to 16, this would be 65,536, which is multiplied to, which is from the multiplication of the previous network prefix of 4,096 usable IPs by 16. So again, to reiterate, as long if you multiply each one by 16, and as you go down the network prefix, which you subtract 4 from, you'll get the amount of usable IPs. So 12 would have about a million, and then /8 would have about 16 million usable IPs. But again, in short, you don't need to know this for right now. So let's go ahead and put a /24. And then we will leave no IPv6 CIDR block. And then leave this as default. And we will go ahead and create the VPC. So let's just go ahead and verify the VPC got created. It's over here. So now we're going to go ahead and create our subnets. So to reach our subnets dashboard, you would just click on the subnets link on the left-hand side. And then you'll go ahead and press the create subnet button. You will assign the subnet that you are creating to your VPC that you just made. And then it will give you some more settings to fill out. For this one is, we're going to be making a total of 2 subnets. So this first one, I'm going to make my public subnet. So I'll go ahead and type my name, and then I'll say public subnet. Availability zone. we'll go ahead and do US East 1A. So an availability zone is kind of so you have your region. So these are different locations within the US. And then now let's say each region has its own subnet or availability zones. So I believe most of them have three each. So an availability zone is just three different locations within that specific region. Choose the uh, CIDR block that you created earlier. And then for this next part right here, I will give you guys a link to help you guys configure your IPv4 subnet CIDR block. Put it in the chat, or I'll put it in Slack. I'll put it in Slack, and then also I'll have it in chat. So this is pretty much this is a subnet calculator. It helps you configure uh some different ranges within this range of IP address that you already have. So this range of IP address is designated for the VPC itself. So for that compound, your network, and then your IPv4 subnet CIDR block. Since we're creating two subnets, a public and a private, each of those subnets need to have their own set of IP ranges. So that's what this calculator does. So if we go up here and give it our network address, and then do a /24, press update, press OK. Like I was demonstrating earlier, this is our range of addresses, and this is our usable IPs. So notice how it says 254 hosts and not 256. That's because this first one right here is our network address. So the first IP address of that range is the network address. It just uh it what am I looking for? It's it pretty much it's a network identification. So it's your ID for the network. And then this last IP address right here is your broadcasting IP. So it's used for broadcasting to all other hosts in the IP range. But since we already have this range for our VPC, we want to go ahead and divide that into two, one for our public and one for our private. So notice how now each host has 126. It should be 128 for both, which adds up to 256. But remember the network address and then the broadcasting IP address. So what we're using for our public IP address is going to be this first one. So we can just go ahead and copy that. Paste it. So we're using a /25, and it gives us 128 IPs. Any questions? Okay, let's go ahead and create our public subnet. And then now we're going to create our private subnet. So we'll go ahead and create a subnet, choose the VPC we just made. We'll type in Eric private subnet. Availability zone. Last time we used US East 1A. This we're going to be utilizing the principle of high availability. For this one, we will put US East 1B so that they are in different locations. So for example, this is you generally use this. It's just a general principle used within AWS. So if, for example, if one subnet goes down, the other one will still be up. And this is mainly more useful for if you have an auto scaling group and it monitors for, say, traffic on the EC2 instance within your public subnet. If there's too much traffic, then the auto scaling group will detect that and create more EC2 instances. So you can set those different EC2 instances within different availability zones. So if one EC2 instance goes down, you still have the other ones up and running. We're going to use the VPC CIDR block range /24. And then now let's go back to the subnet calculator. We're going to use the second subnet address. And this one goes from 128 to 255, which is the second half of our original address. Gives us 128 IPs. Go ahead and create subnet. I was wondering why the public subnet wasn't there. So we have our public subnet and then our private subnet. Now let's go ahead and get into the internet gateway and go ahead and create it. On the left-hand side, you'll see the link for it. Go ahead and click on it. Click the create internet gateway. Go ahead and put your first name, dash IGW for internet gateway, and go ahead and create it. Oh, I forgot a step. I forgot to attach the VPC. So, or I don't think you can configure it within the configuration itself. But if you need to attach the VPC to the internet gateway, you go to the Actions tab on the top right corner, attach to VPC. You select the VPC you just made. You could also do it through the CLI and then attach it. So now the state says attached and has your VPC ID. Next thing we want to do is route tables. So we'll go ahead and create a route table. We'll name it Eric route table. Let's try creating one for right now. And then we'll go ahead and attach it to our VPC. And Cam, I'll show you why this one route table won't work. So as we progress, you'll see. Okay, so we created a route table. And then we have to go to the details page of the route table we just created, which we are on right now. And then we have to go to the routes tab. Click on the edit routes button. We're gonna add a route. So right now this route table, if it sees a destination within this range, it'll target locally. But we want to add a route to the internet gateway. or for actually for this we're gonna do anywhere for internet, and then target is internet gateway. Then a pop-up will show up below. Click the one you just made, and then you'll hit save changes. So now you have destination for this IP range, and then anywhere. Now we're going to associate our subnet to our route table. So to do that, you just go to your subnet. Let's do a public subnet, and then click on your public subnet. Click on. You're going to get into the details of your public subnet, and then find the route table tab. Go to the edit route table association, and then choose the route table that you just made. Notice that it shows both of the destinations that it has, or both of the routes. Go ahead and press save. Let's see if we can add a route table to our private. Let's try it. Okay, and then now after we associated our subnets with our route tables, we'll go ahead and okay, actually we can't even, let me take that route table back off, because even just looking at it, remember you don't want your IP address from the subnet to be accessible. So this route table needs connection to the internet. So this private subnet can't have this specific route table. So we're going to have to create a new one. But before we do that, let's go ahead and create the NAT gateway, so that the private subnet can go ahead and reach that NAT gateway within the public subnet, and then reach out to the internet. So the big reason why we can't do that in this case is for security reasons. So go ahead and navigate to the NAT gateway. Create your NAT gateway. Just do air NAT gateway. Select the subnet. And this is the second drop down is specifying where you want to create that NAT gateway, and it is going to be within our public IP or public subnet. Gonna leave this as public connectivity, and we do want to associate elastic IP address to this NAT gateway, so that the private subnet can go ahead and reach it. So we'll go ahead and allocate an elastic IP. It says it's been allocated. We'll go ahead and create the NAT gateway. Go back to our subnet. Go ahead and or before we one more thing before we get rid of that route table. Let's go ahead and create another route table for the private subnet. Okay, I guess you can't associate the VPC, or that was for the internet gateway. Okay, so we have our routes for the private subnet here. We're going to go ahead and move this route table to the other one so that it doesn't have the internet destination, and it just it just sends out traffic to within our network. Does that make sense on why we had to create a new route table? Anybody confused on that part?
Could you explain it?
Yeah, so when we created the route table for the public subnet, our first route table needed to be able to reach the internet. So that uh yeah, that route table just needed to we need to have a route table that is able to reach the internet as well as send other traffic that is not being sent out to the internet within our network. So that's why we have two destinations within here. This destination just targets everything locally, and then we have the second destination that targets the internet. Now for the private subnet, we don't want this subnet to reach the internet because it's a private subnet, has a private IP address. So we cannot have that other route within here to send out the traffic to the internet. So we can
So if
have
you were
that.
to use the same route table as before, it would pass that traffic on if the
Yeah.
IP address is correct,
Yep.
right?
Yep. Yep.
So you
Exactly.
can't just edit the first one, or do you need both?
Well, the first one needs traffic to the internet, so that's why we can't remove
Okay.
that specific 0.0.0.0 IP address. It needs to stay on there. So that's why we created the second one, which doesn't have it for our private IP, for our private subnet.
Okay, thanks.
Does that clarify it at all?
Yeah, you need both. Yeah, thank you.
Yep. Any other questions? Okay, let's go ahead and I think that's the end of the lab.
Eric, I have a question.
Yeah.
You you have to know what you're doing here because like you can mess stuff up, right? Like you could think like you're doing private, but you're like blasting, broadcasting out. Like, is there a way to like test before,
Well,
making sure you're like buttoning up all the holes and all that?
honestly, if you'll see once you get into the challenge, once you start trying to have everything talk to one another, you'll just get
Mhm.
errors saying or it can't reach it or something. Uh,
Okay. Okay.
or final case within the challenge is trying to access the application that you put within your uh, public subnet and trying to access that URL, but maybe it's not working or it won't load. So that's how you know a component is missing. There's no connectivity uh, uh, flowing through it. So
Yeah, I wonder though, like, say it does work, but there's still holes that you don't really know till like, you're on news or something, right? Like,
like for you're
yeah, is
talking
there
about
like,
maybe like For example,
Does AWS offer something where I don't know, like,
yeah,
are you
I believe there's
sure?
AWS resources that check out different things like, for example, like it'll check out if you have bugs in your code. There's I'm pretty sure there's one for your network as well. So
Mm. I think
if
that's
not,
why we
there's
gotta
some
have
probably some third party or something. You can
yeah, and
Hey
linking
Cam,
them
what are
up.
you asking? Are you asking like if you mess up a config file or something and everything crashes, or
Yeah,
you just
like
mess
say
up
for
like a
example,
setting?
we want it to be private, right? And I'm a newbie. I'm like, oh, I think it's private, but it's like straight public, right?
Yeah,
And
yeah.
like
That's
I
why
expose
everything,
stuff inadvertently.
all your
Um,
so that's why you and me cannot do anything in Amazon that we're not supposed to, right? Like,
mhm.
have you tried to change a user or have you tried to make any other settings that we're not supposed to? Everything's grayed out because Code Platoon has a very strict policy on what students are allowed to have. Companies have the exact same policy in regards to junior devs and where your permissions are and what you can play with. But it's very structured. It's part of what they call what do you call it? Does anybody know whenever the source of truth of what they're trying to teach us? Or not teach us, but what the policies are. I'm on my bad. I'm
No, thanks.
No, yeah, yeah. So speaking more towards the class, like you're not gonna mess anything up because just like what Jesse was saying, we have policies in place through the IAM service. So that's where you can actually give permissions and access to different users. So you're not gonna be able to uh, mess anything up that way, or there's nothing dangerous gonna no security breaches or anything that's gonna happen through it. All good. All right. Let me see. All right. Are there any last questions on what we just went over? We went over creating the VPC, creating the two subnets within it, implementing a security group, implementing an internet gateway, as well as route tables and a NAT gateway. Any questions on any of those components or what what we went over today? Okay. If there's no questions, let me go over the challenge of the day real quick. All right. So for today's challenge, you're pretty much going to be doing everything we just did, but you are going to try to deploy this Dojo Jump application onto one of your subnets. And you have to be able to access that application within the URL. Go ahead, Kevin.
Uh, Once we do it, do we need to push that out and do we need to do a pull request, or how do we show we did it?
No, we'll just go do some demos later.
Okay.
So, yep. And then if you get done with it early, just work on past challenge assignments that you may have. Any questions?
Hey, Eric, can
Yeah.
you post this video just so I have it available? I missed some of it.
Yeah, I'm going to work on getting that up right after this lecture.
Thanks.
Yep. All right, if there's no questions for me, go ahead and take your 15-minute break and then just go ahead and come back and work on those challenges. I'll create some breakout rooms.